In our childhood, we are so amazed when the broken appliances are broken and opened, where we see the components and the details on the appliances. Perhaps have you seen this one? Hi, I am Johari and today we are going to talk about resistors. Yes, you heard it right. They are called resistors. A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. The value of a resistor can be measured with an ohmmeter, which may be one function of a multimeter. Hence, the unit for resistor is ohms. If you think those colorful bands on your resistors are there just for show, think again. Those bands tell you the value of the resistor. Before you can decode the resistor value, you need to know a little more about the resistors. So basically, there are two main types of resistors. It is a standard resistors and the precision resistors. Standard resistors have 4 color bands. 3 of the bands tell you the nominal value, which means the value the resistor was designed to have. The 4th band tells you the tolerance of the resistor, which indicates how far of the nominal value the actual resistance could be. Precision resistors, on the other hand, which have more precise values than the standard resistors, have 5 color bands. 4 of the band tells you the nominal value. The 5th band tells you the tolerance. This figure here shows a diagram of the color code of a standard 4-band resistor. You use this color code to figure out the nominal value and tolerance of a standard resistor. In this video, I'm going to talk about the step-by-step procedure or steps on how we can use this color code to figure out the nominal value of the resistor. First step is to decide which band is the first band. Compare the ends of the resistor. Usually, the color band at one end is closer to that end than is the color band at the other end. If that is the case, the band that is closest to one end of the resistor is the first band. If you can't determine which is the first band, look at the 2 outer bands. If one of the outer bands is silver or gold, that band is probably the last band. So the first band is at the other end. For the second step, look up the color of the first band in the column labeled first digit and find the number associated with that color. This number is the first digit of the resistance. In the resistor shown in this figure, the first band is yellow, so the first digit is 4. Next, we are going to look up the color of the second band in the column labeled second digit and find the number associated with that color as well. This number is the second digit of the resistance. In the resistor shown in this figure, the second band is violet, so the second digit is 7. Then, we are going to look up the color of the third band in the column labeled X and find the number associated with that color. This number is the multiplier. In the resistor shown in this figure, the third band is brown, so the multiplier is 101. Next, we are going to put the first 2 digits side by side to form a 2-digit number. For the resistor shown in this figure, the first 2 digits are 4 and 7, so the 2-digit number is 47. Then, we are going to multiply the 2-digit number by the multiplier. This gives you the nominal value of the resistor in ohms. In the resistor shown in this preceding figure, the 2-digit number is 47 and the multiplier is 10, so the nominal value is 470. If you have a precision or 5-band resistor, the third band gives you the third digit of the resistance and the fourth band gives you the multiplier as shown in this picture. Resistors with 6 bands are usually for high precision resistors that have an additional band to specify the temperature coefficient. You just have to follow the same step we used in a 4-band resistor, but this time more digits are involved. To figure out how far off from the nominal value the actual value resistance could be, we could look at the 4th band on the standard resistor or the 5th band on a precision resistor. Refer to this figure for the color code for the tolerance of a resistor. Say that a 4th band of the 470 ohms resistor you have chosen for a project is gold. The color gold in the column labeled tolerance in the figure represents a tolerance of 5%. Because 5% of 470 is 23.5, the actual resistance could be as much as 23.5 ohms higher or lower than 470 ohms. So the actual value of the resistance could be any value from 446.5 to 493.5 ohms. Most standard resistors have tolerance of 5%, 10%, or 20%, and most precision resistors or 5-band resistors have tolerances of 1% or 2%. For the majority of the circuits, it is okay to use a standard resistor. For certain circuits, it is important to use a precision resistor with a lower tolerance.